What is going on, guys? Welcome to your 15th physics lesson. And in this lesson, I want to talk to you guys about terminal speed, or as some people call it, terminal velocity. Now, I know that that's a movie, but I'm actually not going to talk to you guys about the movie. I want to talk to you guys about the physics term. So you know how a couple tutorials, I don't know if we were like on a plane or on top of a building, but I said that if you were up high, we'll say we're on top of a building, and you were holding something, we'll just say it's a cucumber, and you dropped it from that building, then it wouldn't just fall at a constant speed. What this object, which just happens to be a cucumber in this case, would do is it would accelerate towards the ground at a rate of 9.8 meters per second squared. And I think I showed you guys how to calculate of how fast it's going to be going at what distance, and I gave you guys a whole bunch of cool formulas. However, I need to mention this that I kind of lied a little bit. It wouldn't accelerate forever and ever and ever. What it would do is it would eventually reach a speed where it could no longer go any faster. Now, if you're saying, why would you mean like when it hit the ground and smash, or what the heck are you talking about? Well, what I'm talking about is terminal velocity. When this cucumber gets to a certain speed, then air resistance would be pushing up on it as an equal force that gravity is pulling it down. Now, whenever it got to this point, then it would no longer be able to go any faster. So basically, if we zoomed in on this object, here's the cucumber flying through the air. Woo, woo. Looks like a loaf of bread right now. But basically, what weight and therefore the force of gravity is doing is it's pulling this towards the center of the earth at a rate of 9.8 meters per second squared. Now, due to wind resistance, or air resistance as some people call it, it's going to be pushing up on that cucumber that just happens to look like a loaf of bread right now. Now, if you guys don't really understand how wind resistance fights against the force of gravity and speed, let me go ahead and talk to you guys about a little example. Say, okay, very funny. Say you were driving in a car, but before you were driving, okay, let me draw my awesome car right here. So here's you in your car, and you have a really long arm. So you are in park right now, not moving at all, and you stick your hand out the car just like that. And you're like, okay, maybe I feel a slight breeze, but today it's not windy at all. So your hand, you can raise it very easy. It's not going to get pushed around. Now, say you were traveling down the highway at 80 miles per hour. Well, now you roll down your window and stick up your hand, and suddenly it's not so easy to hold up your hand. Due to your speed and wind resistance, it's going to be pushing on your hand this way. Even though speed is going to be moving you, the car, in your hand 80 miles per hour in this direction, the wind is going to be pushing and making your hand go in the opposite direction. So again, speed and wind resistance are working as two counter forces going in opposite directions. Now the same exact thing happens with this cucumber, except instead of a car, you got gravity working for your speed. So gravity is pulling it down and the wind is pushing it up. All right, wind right here, so you guys know what I'm talking about. And whenever pretty much the force of wind or air resistance equals the force of gravity, then you pretty much come across something called terminal speed or terminal velocity. So again, one last time. The point in time when air resistance equals the weight of the object would no longer accelerate, aka it won't go any faster, and it would just move at a constant speed. So again, this point in time is called terminal velocity, or the object's terminal speed. And in the upcoming tutorials, I don't know if it's going to be the next one, but I'm going to show you guys how to calculate terminal speed, pretty much how fast can an object go when you drop it from, a building or a bridge or a plane or something like that. So that's what terminal speed is. Hopefully you guys understand. Thank you guys for watching, and I will see you guys in the next lesson.